Hello everyone, this is Ali Reza. Today we are diving into history. Before we go and talk about programming, we need to know how a computer works. When we talk about computers, you may think about something like the lower right picture, a monitor, a keyboard, a mouse, and a case. However, this was not how they were actually 20 to 30 years ago. Not long ago, but yeah, I know, 40, let's say 40 years ago. And there is a very nice article that you can read from Auckland, New Zealand University. He's going to teach you the whole history about the very first computers and how they became in life. The interesting part is this. George Boole was the first guy, 1854, who wrote an article, a book, about how we can convert our thoughts into a logical phase of mathematician equation. And it stayed as a philosophical concept until much later, when people understood how to convert that logical thinking into true or false and basically 0 and 1 and implement it in circuits and relays and convert it to something electronic. Then it became switches, then yes, it became this. We will look at more pictures like that in just a minute. So this was the very first guy, George Boole, who thought about converting our mathematicians' thought process, everything, into something that is representable by a very simple logic. These days, if you look at Java, C#, or even C++, almost every language out there, it has a Boolean variable type named after George Boole. And Boolean is just a logical type of variable that accepts true or false. We will talk about it later. But they named it after George Boole. So that was the first article. However, let's see what computers were looking like. And by the way, the picture you are seeing right now on the left side is a combo of a video editing station in front that the girl is sitting behind, and it's a video tape that she has in hand, and a computer on the background near the wall. So ignore the station in front and look at the background. There are lots of lights and switches here and there. All it is doing is just computing stuff. And it's a very, very basic relaying computer. Now, I will come back to this top right picture later, but let's take a look at how computers were like in old days. As you see, they were tapes, and this is, by the way, more advanced computers. Yep. But they were tapes, and they would take a very huge space around the walls just to have these tapes moving around and, playing. And yep, if you look, this whole building is just one single computer. Don't think about many computers. No, this whole thing is just one single computer. And same goes here, same goes here. These are all one single computer, not just a case or a monitor or a keyboard. Okay, so before the tapes, there were days that programmers had to punch cards. And God, I remember having one of these myself. I got it from my father as a memento. They had to punch these cards, a physical piece of paper being punched, and they would put it inside the platform, and the platform would put some light in it, and the light would pass through the punches so that the receiving end would receive the light, and it would understand one of two cases. Either the light was presented or it was missing. So it was 1 or 0. And God help you if you had a wrong punch, one single wrong punch, you had to do it from scratch. Yeah. And this was the very first language of programming a computer, 0 and 1. And actually, this is still the same way of programming a computer, because computers are electronic circuits, nothing beyond that. And they just understand 0 and 1, presence of electricity or absence of electricity. There is no other way to handle it. If you think about it, that's the only way. Either there is a presence of electricity in the circuit, or the circuit doesn't have electricity. There is no other way. So this is how computers work in back end. Now there is another interesting thing to show you, and this is it. An IBM 5100 portable computer, 1973. And look at the memory, 64 kilobytes. And what's the price these days? 20K. Yep. Okay, for 64 kilobytes. Okay, and it was an upgraded version from 16 kilobytes. Holy crap, 1973. And these were accepting different type of interfaces. You see that we have keyboards here now, not punch cards. Okay, so this was how computers would work back in old days. So how did they work these days? Because we all are familiar with the keyboard. We are typing, and computer understands it. How is it possible? There are middlewares that sits between your physical keyboard and different aspects of a computer. Now, a computer have different units. Let's talk about these units, because if you don't understand these units, then you don't understand anything. We have a CPU, a GPU, and these are the main cores of what you understand these days. But there are other parts behind the scene, and I'm not going to dive into them because they are old-fashioned teaching, and you don't need to do that. Okay, so CPU is Central Processing Unit. It's the brain of your computer. It's an electronic circuit sitting on your motherboard with a fan on it, and this is what is responsible of understanding everything. There is another thing that is GPU. This sits in your graphic card, graphic processing unit, and it's responsible of doing heavy math, because graphics are all math, and it has to do lots and lots, millions of math equations per second to just draw your mouse moving on your monitor. And these two work hand in hand with each other, okay? What combines these two together is the motherboard. We all know that. It's the circuit that sits behind your case, has the CPU on it, and the slot for your graphic card. What about the keyboard? Now the keyboard is just some buttons that being pressed, okay? Either it's pressed, that means we have 1 for that keyboard, or it's not pressed, and we will have 0 for that circuit on the keyboard. Then it will be transferred by a cable to your motherboard, and motherboard will transfer it to the CPU, and CPU is responsible of somehow understanding what is going on. Now, how does it understand? Is by something we call drivers. And if you ever installed Windows or any other operating system, you'll be familiar with this word, drivers. Sometimes you see that some guy guides you that, hey, update your graphic card's driver. Now, driver is a piece of software. Its sole purpose is to translate these electronic currents to something that CPU and your GPU will understand. Okay, let's go a little bit forward and see what will happen when we move our mouse. Again, we are sending some electronic currents. When we are typing, we are sending electronic currents, and our CPU, GPU, motherboard, and different parts of these electronic hardware will understand what is going on. If we want to have a piece of program, for example, we want to type 1, 2, and 3 by our program. So we don't want to hit the keyboard, but we want to play a program and run a program, and that program will print 1, 2, 3. How that happens? Back in old days, we had to work with memory in such a language that computer would understand, and it was called machine code. We will look at that in the next video and see how machine code looks like. Okay? So back in old days, we were working with machine codes, either with the punch cards or later down the line when we had the keyboard, we would type in machine code. And these days, some students in university learn assembly language. Assembly language is the closest language to machine code. However, machine code is really hard to understand, and honestly, beyond the very first days of computers, it's impossible to handle it by a human, because just for printing a single 1, you have to write near 20, 50, maybe 100 lines of code so that the computer would understand where to put that line and what to put in the line and what characters should be there, so that it would show 1 in a very specific position on your monitor. So it's 100 lines of code in machine code. And we will, as I said, take a look at this and understand that it's almost impossible for a human these days to write a machine code directly. Assembly is another story. You can handle assembly yet, but no one writes assembly anymore, because again, that's a very long way of doing something that can be done much simpler these days. Okay, beyond machine code, we will write some code in a human understandable language. For example, if we want to have 1 in a line, in many languages we have a command named print. Okay, that's an English word, isn't it? So we will say print, and then we use some special characters. This tells the computer that, hey, we are putting some text somewhere. And then we put the text between these special characters, and if we run this program, computer will print 1 for us. Few words gets the job done. But how is that possible? Now, here is an interesting concept. You may hear the word interpreter, or you may hear the word compiler. Some people use these 2 words in placement of each other, but that's wrong. Compiler is one thing, interpreters are something else. Now, you are writing in a human understandable language. We call it high level language. What computer understands is machine code. Machine code. So we need something that will translate our high-level language, something that we understand, into 0 and 1, or machine code, or something that computer understands. We have these two that will do this. So what is the difference between a compiler and interpreter? If both of them are changing our high-level language into machine code, then what's the difference between these two? The difference is fundamental. A compiler needs to understand the whole program before converting it to machine language. So the compiler will read your whole program and then convert it to machine code. So when we are using a compiler, our code becomes much more compact and they will work faster because compiler understood all the things you have written and it will do tons of optimization and convert it to machine code. However, it's a slow process because compilers need to read everything, understand everything, and they will check tons of error checks and they say, okay, everything is okay. Now I need to tweak your code and make it compact, make it optimized, and then convert it to a language that machine learns and understands. And that takes a little bit of time and it's a little bit of memory consuming. However, as I said, the programs that are being compiled works faster and they are smaller in size. And there is one issue with compilers, and that is they only catch errors when they are syntax or semantic errors. Okay, we will talk about this syntax and stuff like that later. But for time being, you should know that compilers only find errors that are related to the language itself. However, what is an interpreter? Interpreter is another piece of software that can convert your high-level language into machine code. However, it is not behaving like a compiler. What does it mean? Is that interpreter will read your code line by line and convert them to machine code line by line as it goes forward. So converting the code is faster. It needs smaller memory usage. However, the final program is almost bigger in size and it runs slower. You need to understand this. The programs that are being compiled, generally speaking, works faster. However, the programs that are being interpreted work slower. It's important to understand this concept because in a few minutes later, when I talk about different languages, you'll understand that some languages, some very famous languages, are using interpreters, and because of that, they are slower against your belief. Advantage of interpreter is that, well, we can compile line by line and go forward, and it's doing it faster compared to a compiler. And because of that, it doesn't need to read the whole program first. However, the disadvantage is that it can only run the program that is reading right now. So it can only run the same program over and over again. And let's talk about which language is using which one of these. So anything that uses word C, the very first language was C, then C++, and these days C# and Java. These are compiler based. We know that when we are writing in C++, Java, C#, and as I said in the introduction video to the channel, a child of C++, MQL. These are all compiler based, so they need to be compiled. However, there are interesting languages here on interpreter. You may hear Ruby, you may hear the name Perl, and you may hear the name MATLAB. And the king of all of them, you definitely hear the name Python. You heard it correctly. Python is interpreter. So based. So it's slower compared to C# and Java. But wait a minute, Python is being used in data science and big data analysis and stuff like that. Yes, when it comes to big data, that's an exception. Python is faster than these two because of the libraries written for Python and because how Python is behaving itself. Python is a language that was developed specifically for big data and analysis and doing scientific research. So it does that math compilation and math programming and math calculation much faster than Java and C++ and C#. However, if you want to use Python for something like a desktop application, and I saw people do it in YouTube, you better to ignore Python for that. Go and use C# or Java for that, because a desktop application doesn't need to do millions of math per minute, and it needs to work faster because the user has to do interaction with it. So C#, Java, even C++, they are better for something like a desktop application or even game programming. That is the reason you see that Minecraft is using Java, Unity 3D is using C#, Unreal Engine is using C++. None of them are being written for Python. And they don't even think about Python because compilers are much better choice for these type of things. Okay? So understanding the fundamental difference between a compiler and interpreter is important. Which one of these should you learn? We will come back to that in another video when we understood everything about basic fundamental information of programming. Then we will talk which language is good for you and what are the opportunities on each language later. In the next video, we will talk about that machine code and a little bit of how this is important. If you like what I'm teaching, please hit that subscribe, like, and the alarm bell so that you can be alarmed when I upload another video on YouTube. And I'm telling you, there will be a video every single day and you will learn much on this channel. Have fun, everyone. Bye.